Hello physics students. Today we are going to be doing an example problem. I'm going to just make two videos, one for each example problem. We're going to be doing an example problem today of momentum conservation. And in this problem we have one object, a big ball, going ahead and colliding with a person, and those two objects are going to stick together. The person is on skates, and when the ball collides with the person and the ball will start to move together. And so we want to find what is the velocity. So afterwards, what is final velocity of ball and person? What is the final velocity of the ball and the person together? All right, so in the previous video, we learned that the total momentum before should equal our total momentum after. So what I like to do in these problems is I like to set up a before side and an after side with a line down the middle. And this helps me keep everything in order, all right? And so what I like to do, start with this, and then I list out every single aspect that I know. So we're given the mass is 15 kilograms, the velocity of the ball is 6 meters per second, the mass of the person is 60, and they are standing still, so their velocity is 0. All we know is that after the collision, they move together as one object. And so we'll talk about what that means in a little bit here. But the first thing that I want to do is I want to calculate the initial momentum, so the before momentum of each object. So the ball has a mass of 15 kilograms, a velocity of 6. Remember, momentum is mass times velocity, so mass times velocity, and so we have 15 kilograms and we have 6 meters per second. So 15 times 6, that's 30 times 3, we have 90 kg ms. All right. So that is my momentum of this object. My momentum of this object is m times v. 0 times anything is 0. So we have 0 kg m over s. All right. Now let's stop there and let's go to the other side. So we found the initial momentum of each object. Then we're going to find the momentum of this object. All right. So ball and person. Okay, mass. Are we given a mass? No, we're not told the mass. But if I, let's say physics pony and I, right? Always got to involve physics pony somehow. But here I am. Physics pony is there. And then physics pony gets scared and jumps into my arms. What's my new mass? Well, it's my mass, but I'm holding physics pony, so I also have physics pony's mass as well. This is the same thing that's happening here. The ball and the person, that object, now that we treat as one object, is just the mass of the person plus the mass of the ball. So 60, 15, our new mass is 75 kilograms. All right. And we want to find the momentum. So momentum is mass times velocity. So we have our mass, 75 kilograms times our velocity. Oh no, well, we don't have a velocity. Well, how can I figure out the momentum? Oh, we're solving for the velocity. Oh, okay. Well, one thing I want you all to know is if I don't have a velocity or don't have a mass or anything like that, just put the variable there. So we have velocity. Now our momentum is 75v. 75 times the variable v. Now, we've said that the total momentum before equals the total momentum after. So I'm going to add up all the momentums on this side and set it equal to the momentum on that side. So 90 kgm over s plus 0 equals 75v. So 90 equals 75v. So now to solve for velocity, 90 equals 75v. Divide both sides by 75. Calculator here. Can't do that mental math. 90 divided by 75, 1.2. So our velocity is 1.2 meters per second. And that is how we solve this problem. Stay tuned for another example problem. We'll do something a little bit more complex.